Hello and thank you for selecting my video. I've published my video online for you and anyone else interested to see my small article about substations and transformers, electrical substations and transformers. I would like to share with you my small article about it. Before I start my video, I will make it very clear that I am not a qualified electrical engineer, and everything I mention in my video are only my own expressions about the subject. Electricity can be deadly and shouldn't be tampered with unless you are fully aware of what you're dealing with. All my expressions regarding high voltages in electricity are only for viewing purposes regarding my videos and not to be quoted on. Electrical substations are places where electricity arrives from the national grid via high voltage overhead power cables fixed to pylons. Electricity may also arrive to electrical substations by underground cables as well. Approximate voltages in the UK. Electrical substations may vary from 100,000 volts to over 500,000 volts. The electricity is generated at various types of power stations around the country, and the voltage is stepped up to an extremely high voltage so that it can be transmitted via along the national grid power lines over long distances. High voltage is better for long distance travel than low voltage at high current. Power in watts is volts times amps. So for a fixed power rating, you can have a high voltage with a low current, or you can have low voltage with high current. The high current with the low voltage will need heavy cables in order to carry the heavy ampage, the current, the amps. The heavy current will need thicker, heavier cables, but the voltage might not necessarily be so high. If it's for the same power rating and you have high voltage with low current, you will need strong insulators, because the voltage is what breaks through the insulator. The voltage is the potential energy. That's what pushes the current along the conductor. So high voltages with low current will need a strong insulation, but may use lighter cables. However, high voltages on pylons, the wires and the cables on them are uninsulated cables. Pylons have uninsulated cables. The cables are high off the ground, out of easy reach, and the natural air around them, which is an insulator, air is an insulator, that will insulate them from ground earth, so they won't short. Protect anybody near them. The air is an insulator. Doesn't conduct electricity. The high voltage pylon cables are insulated from the pylon structure via glass or ceramic dish-like components. It's the funny shaped round circular discs, or interestingly shaped discs that are on pylons. They can be made from glass or ceramic, but they're strong insulators to insulate the high voltages from the actual metal structure. That's what these interesting structures on the ends of the cables, like round dishes on pylons. Sometimes are brown, sometimes are clear glass, greenish kind of colour, but they're insulators anyway. Electrical substations are designed to distribute the electricity from the main national grid pylons to different local power line networks, which will serve the local areas. You may think of it like this, as the motorway being the national grid and local power lines being the smaller side roads. So you get the main national grid would be like the motorway, the local power lines would be like the side roads, and the substations would be like the big traffic junctions, like big roundabouts, traffic roundabouts. That would be like your substations. You could think of it like that. When power is generated at the power station and ready to be sent along the national grid, the voltage is stepped up with step-up transformers. When the electricity gets to the local substation, it will be ready to get distributed around. Because electricity doesn't need to travel so far now locally, the transformers in that local substation will reduce the voltages to a safer level, because it's nearer the ground and nearer people. The The current will increase proportionally with the decrease in voltage, and the power in watts will remain the same in theory, but because nothing's perfect, you've always got like energy losses, most due to resistance in the form of heat, resistance in the conductors. So there are energy losses. In theory, it should be the same power, but because there's energy losses through the transmission of the electricity over long distances, you will get resistance. So you'll get energy losses in the form of heat, and of course, if you hear anything from it, sound, arcing, that's also energy. It's just being converted from a different state. When electricity leaves the distribution substation, the voltage will still need to be transformed down yet again before entering someone's house. On-street transformers are there to do that job. In Britain, the voltage is usually around about 240 volts at someone's house socket. Voltages in the national grid could be up to 500,000 volts or even more. These voltages are far too much for someone's house socket, so therefore need to be transformed right down. Electrical substations have all sorts of switchgear, monitors, transformers, controls, cables, heavy duty insulators, and structures to hold everything up. There's buildings to house all the switchgear and controls. Substations also have big security fences and clear high colour international warning signs. Where there is a demand for electricity, a substation and transformers will be nearby. In the next clip to my video, I've taken footage of a big substation within the Angus area near Dundee in Scotland. In that last clip, you may have heard the buzzing sound. That sound is from the big transformers. It's the 50 Hz cycle, the AC sound from the alternating current within the transformer core. Around the transformer core are the primary windings and secondary windings. Coils of wire around the transformer core, the windings. Transformers work using the induction process. AC alternating current in the primary winding induces current in the secondary winding. Depending on the number of windings on the core, you'd either step the voltage up or step the voltage down. But proportionally, the power will be the same. The current will drop if you increase the voltage. If they step the voltage down, the current will increase. You step the voltage up, the current will decrease, but the power times current will be the same. That's what watts. Power's measured in watts, joules per second or something, but watts anyway. The AC current alternates 50 times a second. The AC current changing directions 50 times a second causes the core to vibrate at 50 Hz audible frequency. That's the humming sound that you could hear from transformers. If it was raining outside, if it were raining outside, the damp air causes the high voltages on the uninsulated piling power lines to arc slightly, causing the arcing sound that may be heard under pilings on a wet, damp day or night. In the next clip, I've taken footage around about a new substation being constructed around about the Aylth way, the new Aylth project for the substation that's being built in Aylth, near Aylth, in the Angus area of Scotland. Hello. Right, and at the Aylth substation project, the new one. It's the first time I've actually seen this. Well, I've been right up to it here, like. I've obviously started it fairly recently. So, I done a video actually a couple of months back. They had this great big transformer. They were moving from the Dundee docks to here. It was about a 200-ton transformer, and it required a special stgo 3 truck to move. A big trailer with about 100 wheels on it. I've done a video on that. If I remember, I'll put a link in the description to that. So they had to transport it by two big. There's a truck in front, massive trailer with 100 axles, and there was another truck behind it. And so the whole convoy must have been about 300-400 tons. But anyway, this is where the transformer ended up. I was in amongst there somewhere. Amongst all that. There's another big substation at Teeling as well. I've got footage of that. I can maybe show that later on. But this is the current energy thing that they're doing. Substation. So I'll turn it around and I'll show you some footage. So it's just on the outskirts of the small Scottish town of Aylth. And they're currently doing something at the Teeling one as well. There's one at Teeling, big substation. There's always one there, but I think they're expanding it likewise. I'm not even sure if there was ever one here, but there's certainly one at Teeling before, but that's grown much bigger and homogenised as well, and they're still in the process of doing that. So I'll see if I can get some footage further along that way for you. So obviously at this stage there isn't any power, well there will be, you never ever assume that there isn't, but they're still building it, so I don't hear any buzzing sounds except that bee, it just flew past. Typically there is a buzzing sound, alright, but yeah, there is obviously, it's still in the process of being constructed. No, I think once it's finished you hear the buzzing, the transformers, or the power sound, but and the arcing as well, because when it's damp you'll get the arcing kind of sound. But yeah, you never ever assume there isn't power. There will be power obviously in there for the machinery it's going into, for on-site machinery, and you never assume that there isn't power. You always treat it as if there is power. Now, I was just wondering what these things are. It's wind directional thing or something. Quite unusual. The shapes, faces on them. Well, it looks like it anyway. Just got to log that in. Yeah, it's silent, so you don't hear anything at the moment. Now, there's maybe some like generators I could hear, but and maybe just on-site machinery or stuff like that. But normally if that's hooked up to the mains, the national grid, that will be, you'll get the buzzing sound. These are powered up. You can hear the arcing in the insulators, but yeah, you just never assume there isn't. You just assume that they are powered up. Never, you wouldn't go in there anyway without authorization. But yeah, it's silent. So I'm constructing that. As you may have seen, there are lots of equipment included in that substation. There is a 200-ton transformer within there, which I managed to get footage of when it was being transported from the Dundee docks to the Aylth new substation where the project's being built. In the next clip, I've taken footage of that monster move, and I'll show you some of it now. This thing is massive. It's just like a road train, In Australia they do trucking, road trains, road haulage, and it's a bit like that. That's what it reminds me of. There's the escort van at the back, so it's too many axles to care to count, to be honest. There's a forklift, or it's reversing back a little bit. You hear the brakes. So it's sort of going backwards, you can hear the brakes singing away there. All axles have got brakes on them, and it's quite an eerie sound actually. Oh, that sounds quite eerie. But yeah, it's definitely some sort of manoeuvrable. I don't even know if it's got the power to get up. I'm going to wonder actually. I'm not quite sure just what they're doing, but that's quite an eerie sound. What's going on there? They probably had lots of warning that it would be a big lorry along here. So I'm actually taking pictures as well. That's why the camera's kind of moving something and taking photographs as well. If I could do that, is I could actually film and photograph. So it's 2 police cars in front and there'll be 1 at the back, it's sure. And this is the piece of equipment. Wow, this is quite close now. It's quite massive when you're next to it. Let's just say it's probably about, as it is, maybe about 15 foot from where I'm standing to above my head, I would say. The weight will be I mean, it's obviously too wide, so that's why they need to have the stgo special, and obviously you've got to include the carrier, that'll make width as well, you see. So the transformers are set width, but then you've got to have the vehicle as carrier, that's going to make it too wide for the, you know, without an escort, so it needs to have that. Then you've got the weight of the thing as well, sheer weight. It's 400 tonnes this whole convoy weighs apparently. Oh, so you just saw me here, I made it. Brake line, and it might be a tyre rubbing or something, I don't know. Because we depend on electricity, we need to have substations. Substations are essential and need to be maintained. Because there are a lot of big equipment in these places, access roads and infrastructure will also be required. Special electrically trained workers are essential for keeping these places in good working order so that our heating and lighting etc. are kept available to us at all times. Electrical energy can be generated basically by spinning a magnet in a coil of wire. How the magnet is spun, that's the mechanical energy side of things. That could vary. The mechanical energy has been converted into electrical energy via the generator. The steam turbines is the popular method for turning the generator. There are lots of different methods for producing steam. Coal, gas, oil burners are methods used. The heat produced in a nuclear reactor is another method to produce the high pressure steam. There are other methods as well to produce electricity. Methods such as solar or geothermal ways. Solar panels use heat from the sun to convert the heat into electricity. A solar panel will take in the sunlight, the heat from the sun, and the light, and it will convert it. It will take the light, the solar light, the solar energy from the sun, and convert that into electrical energy. Geothermal is heat from the sun, which is stored in the Earth's ground, stored in the ground. That could be converted into electrical energy as well. They could harness the heat from the ground when the sun's beating on the Earth's surface, on the planet, on that ground. That acts as a storage heater. The ground will act as like in the same principle as a storage heater. The rock will retain, the ground and earth will retain that heat. So that heat could be then harnessed and converted into electricity, and it could be put into the national grid. Whatever method may be used to produce electricity, If it's going to be put into the national grid, then it will have to go through substations somewhere along the line, somewhere along its journey. Then it could end up in a house wall socket or a light switch, or it could end up in factories and all other places that require electricity. They use different phases. They have 3 phases of electricity as well, but basically that's what it was, just in a nutshell. So, I hope you enjoyed my short video, and if you wish, you could comment, like, or subscribe to my YouTube channel. Thank you for watching.